All right, so we're gonna start off doing a couple from the 5.5 assignment, and then we'll look at the practice test. Okay. Which one you want to look at first? Okay, you get it right.
But in general, I guess like 8, 9, and 10.
8, 9, and 10.
On some parts, I was having to do that substitution, which I don't know if that's right. Like, I got it right.
Okay. Yeah, so was 8 the one you were working on then?
Yeah, sure.
Okay. All right. So yeah, you do have to do substitution on that one. So let's see, we got 4 to 5 x times the square root of x minus 4. Okay. So if I'm looking at that one, then looks like for you, I would try x minus 4. Oh yeah, so this is one of the tricky ones, right? So then du, you just get 1 dx. Yeah, I thought I had one in there, and then I didn't see one, so we didn't do one exactly like this in class. So yeah, we do need to look at this.
Video I watched had it where he was like reorganizing it
Before he differentiated. Okay, so the way I would do it is I would do that, and we get 1 dx, and then on this one, we're missing an x term. So what we can do is we can take our u equation and solve it for x. So now we add 4 to both sides. X would be u plus 4. Yeah. So yeah, I need to watch the video and see exactly what they do.
We kind of skipped over steps. We didn't talk about it.
Yeah, it's hard to follow. And then also we can change our limits of integration. So when x is 4, u would be 0. And when x is 5, u would be 1. So we could figure out this from 0 to 1. We'll have square root of u for the x. We said that's u plus 4. And then du. That's what I would do on that one. And then we could multiply. So that's u to the 1/2, so we'll get u to the 3 as plus 4 u to the 1/2. And from there, it just works out like all the rest of them.
So in this one, you're kind of substituting twice.
Yeah, you kind of got 2 substitutions going on. Because when we found du, that didn't cover everything. This part was du, but then we still needed something for the x to take care of the x over there. So typically what you can do is, hopefully, you can solve the u equation in terms of x, and then you can make that substitution. So, yeah, I thought I had one in there, and then I didn't see it when I was looking. So since we didn't do that till just now, I will adjust the grade on 5.5, and I'll count that one as like a bonus problem or something. we haven't done one exactly like that. And then 9 is not bad. You x squared plus whatever number you got, and then you'll get 2x dx. That's just natural log. Then on 10, it's just regular as well, because you'll get 10x to the 4th dx, and you just bring a constant factor 1/10 up front. It's okay. So 8's the only problem child on there, I think, where it's a little more difficult. All right. So look at the practice test, and you won't have one like number 8 on the test. So. Okay. So let's see. This part wants us to get an estimate for the area under the graph here. We want a lower estimate. It says use 5 rectangles. And we want the area between 0 and 10. So if we're using 5 rectangles and we're going out to 10, each one will be 2 wide. And then we just want to read the values. The main thing here is how do we set up our rectangles, because it says we want a lower estimate. So we want to make sure the number we get is too small, not too big. So which endpoint should we put on the, so like our first rectangle is going to go from 0 to 2. Which endpoint do we want on the graph? Left or right? Right on this one. That way we'll get an underestimate. Like that would be our first rectangle. Then this would be, well, missed a little bit. That would be our second. That would be our third. That would be our fourth, and then that would be our fifth. So each one's 2 wide. So it's going to be 2 times whatever the height is on these. So we don't know exactly what the function is on this one. I think it just says estimate. So need to figure out our y values here. So that point, what do we want to call that? It's between 3 and 4, a little bit closer to 4, I think. So we'll call it like 3.6. What do you think? Plug okay? Got to know how tall that rectangle is. Looking at this one now, it's a little over 2. Well, maybe somebody give me an estimate there. 2.1 or 2.2, somewhere in there. Okay. Yeah, we'll get close. Well, I mean, we're just estimating. So, next one. So that's 1 point something. What do you want to call it? 1.2. Okay. And then we're a little under 1 for the next one. So 0.9. And then the last one looks like it's about half to me, so I'm going to call it 1.5. Oh, so if we add those up, get 8.3 multiplied by 2, I'm getting about 16.6 there. So somewhere in that area, in that neighborhood. Okay, if you're doing it yourself, you might get slightly different because we are just estimating here. And then it says sketch the rectangles that we used. We kind of got that already. Should be that one. Yeah, I guess we could have just looked at theirs after we figured out how to set them out. Okay. And then it says do the same thing but do an upper estimate. So all we're going to do is we're going to use these rectangles. Okay. The ones where the left end points on the curve, so we get an overestimate. Okay. So let's see. Again, each one's too wide. The first one looks like it's right at 6. The second one's 3 point something. What do you want to call it? Right here. Okay. And the next one's a little bit over 2, so what do you say? 2.1, okay. And then this one's a little over 1, maybe like 1.3 or something like that. And then the last one's a little under 1. .8. Okay. Okay. And if we add those up, 13.9. And let's see, times 2, 27.8. That's this part. Okay. And then I'm good with that. We don't have to do it again. Okay. As long as you can get an estimate using some rectangles, you'll be in good shape. Okay. Just multiplying how wide the rectangle is by how tall it is. Okay. Questions on that one? You good on why the first one's an underestimate and the second one's an overestimate? Because on the first one, we're missing that piece, missing that piece, that piece, that piece, that piece. So our number we get is going to be a little too small. And then on the next one, we've got that too much, that's too much, that's too much, that's too much. So it's going to be a little bit too big. All right. Number 2, for it to come from arguably one of the most impactful theorems mankind's ever come up with, it sure is an easy problem. It says use part 1 of the fundamental theorem of calculus to find the derivative of that function. Function is defined as an integral. So to get the derivative, what happens if we take the derivative of an integral? Yeah, they cancel out. And then what happens specifically here is that the t turns into an x. Okay, so we would get square root of x to the 4th plus x to the 6th. Turns into whatever variables there. Okay. Let's hit the derivative, cancels out the integration. Okay. Another way of thinking about that is that if this is a function of x, then the derivative's got to be a function of x. Well, questions on that one? be almost a gimme if you get one like that. Okay. All right, number 3 says evaluate the interval, and we've got a definite interval, so we're going to end up with a number as our answer. So first thing we need to do is find an antiderivative. On this one, we don't have to do anything too fancy. It's just like the reverse of the power rule. So we would add 1 to the exponent. So 2 plus 1 is 3. Divide the coefficient by the new exponent. So it was a coefficient of 1, so now it'd be 1/3. If you want to write it x cubed over 3, that's the same thing. For the next one, if we add 1 to the exponent, we'll get x squared. And then we got 2 divided by 2. It's just 1. And just to save room, I'm going to move that over. And then for the last term, we got -8. If we find the antiderivative of that, what are we going to get? -8x. Yeah, we just add an x. Then we need to evaluate this thing, 7 and 9. So plug in the top number first. And then subtract everything that comes after that, so I like putting a bracket. And use the bottom number. And then it's fine if you want to just go to the calculator there. I'm going to do the first group and then the second group just so we can, it's easier to check if we get different answers. Let's see, so 9 cubed times 1/3 plus 81 minus 72. I get 252 from those first 3 terms, and then minus 7 cubed, 343 times 1/3 plus 49 minus 56. That's 322 over 3. So final answer, pretty ugly. You get 434 over 3. Anybody else try punching that to see if you got the same thing? If it'll show up. Questions on that one? Good. My high school kids sometimes, what they'll do is they'll forget to take the antiderivative. They'll just take this thing and plug in the 9 and 7. Okay? So remember, we got to actually do some calculus in here. Okay? So this step's the calculus step, and then everything after that's really just arithmetic. Okay? So this is the calculus step here. So don't forget that part in calculus class. Okay? Oh, okay, because so we get a 2 as our exponent, and then we do 2 divided by 2, we get 1. Right, yeah. I just didn't write that part down, but yeah, so you would get 2 over 2x squared. And that's just x squared, yeah.
If there's a number out in front, you always get that divided by
That divided by whatever the new exponent is. Yeah, yeah. Yep. Yeah, so like on the first one, we had a 1 out front, right? So you get 1/3. 1 divided by the 3. Yeah. Other questions on that one? Good on it. Okay. 4, we've seen a few times. Okay. Just a little bit here. So I'm just going to rewrite it as x to the 1/2. Make it easier for us to get an antiderivative. So for our antiderivative, we add 1 to the exponent. So 1 with a common denominator of 2 would be 2 over 2. So if we add 1 over 2 to 2 over 2, we get 3 over 2. And then we got to divide by 3 over 2. If you remember your fraction rules, when you divide by a fraction, that's the same thing as flipping and multiplying. So we get 2/3 x to the 3 over 2. And then we want to evaluate that from 4 to 9. Okay. So if we plug in the 9, we could bring the 2/3 out front and save it to the end. I'm just going to write it this way this time. Okay. And if you wanted to, you could also work with it like this. That's the same thing. Okay. So then let's see, square root of 9 is 3, 3 cubes, 27 times 2. So this first one works out to 54 over 3. And then the square root of 4 is 2, 2 cubed is 8, 2 times 8 is 16, so minus 16 over 3. And then 54 minus 16, yeah, 38 over 3 there. Okay. And again, I'm fine if you just go from here to here, that's fine, because you could just type this whole thing in and get 38 over 3, that's no big deal. Okay. You want to show me what you're plugging in though, okay. And then after that you can go to the calculator. It's fine. Okay. Okay. Questions on that one anywhere with the fractional exponents? Is that it? All right. 5. Got another definite interval. I promise I didn't make all these definite. Okay. So I need to rewrite this one before we can find the antiderivative because we don't have any kind of integration rule that deals with it in that form. So what can we do to rewrite that one? Yeah, but both of them over v to the 5th. So have v to the 6th over v to the 5th plus 4v to the 8th over v to the 5th dv. And if you don't want to write that step out, I'm fine with it. You can just, if you're comfortable with it, you can go straight to the simplified version. It's fine. Write it down if you want to. So v to the 6th over v to the 5th is just v. And then 4v to the 8th over v to the 5th. So remember our exponent rules, we subtract. So we'll get 4v to the 3rd. Now we can find our antiderivative. So working with the v part, if we add 1 to the exponent, we get 2. Divide the coefficient by 2, so we get 1/2 v squared. Working with the 4v to the 3rd part, if we add 1 to the exponent, we get 4. And then we've got a 4 out front, so 4 divided by 4 is just 1, so okay. And then Want to evaluate that from 1 to 2. This one's not too bad looking anyway. So use the top number first, so 1/2 of 2 squared plus 2 to the 4th minus 1/2 of 1 squared plus 1 to the 4th. Okay, so let's see. Half of 4 is 2, and then 2 to the 4th is 16. And then 1 squared is 1, half of that is 1/2, plus 1. So let's see, 18 minus 3 over 2, 33 over 2. Uh-huh. If it's just like off to the side, it'd be okay. Yeah. Yeah. Like if it's down here or something. That's fine. Yeah. Yeah. And then sometimes people will put brackets on both sides too. Things like that. So if you like that. Yeah. That part? Okay, all right. So here, so the first term, that's v to the 6th minus 5. V to the 6th minus 5. So that's just v. Yeah. That's just the exponent rule. If you got oh, here's another way of thinking about it. Okay. V to the 6th says we got 6 v's. V to the 5th says we've got 5 v's. And then we start canceling. We got 1 v left. Yeah. The short way of doing that, instead of having to write it out like that and cross them out in pairs, is to subtract. That's just the exponent. Yeah, I got you. Yeah. Good. And then similar situation with the other one. The 4, nothing happens to it because it's just hanging out there as a coefficient. So we're just combining the v's, so there we'll have 8 minus 5. So that's 4v to the 3rd. Yep. Good with it. Okay. Other questions on that? Can't think of anything. Yeah, anytime the algebra doesn't make sense, let me know. We can work on that. That's no problem. Okay. So let's see. Number 6 here. Screen will scroll. There we go. This one looks worse than it is. Okay. So we got 8x to the e power plus 9e to the x power. We want the integral from 0 to 1. It's not that bad. We just stick to the rules and don't panic. So to get the antiderivative, we don't need that. To get the antiderivative of the 8x to the e power, our rule is we add 1 to the exponent, so that's e plus 1. And then we divide our coefficient by our new exponent. That's e plus 1. the second part of that is even easier, right? Because it's e to the x. So the antiderivative of 9e to the x is just what? 9e to the x. And then we're going to evaluate from 0 to 1. So remember, e is just a number. So it's not that bad. So here, let's see what we get. So if we plug in 1, get 8 over e plus 1 times 1 to the e plus 1 plus 9 times e to the 1 minus. Now we plug in 0, so that's 8 over e plus 1 times 0 to the e plus 1 plus 9 times e to the 0. And then we'll just see what simplifies from there. 1 to any power, what's that going to be? 1. So this whole mess is just 1. E to the first is just e. 0 to any power, what's it? Okay, 0 to any non-zero power, what's that? 0. So this whole thing's 0. And then e to the 0th power, what's that? 1. So a lot of this cleans up here. So we've got 8 over e plus 1 plus 9e minus what's left in the brackets, 9. That's a number. So. Kind of messy looking. I might not give you one that's that messy, but it's not too bad. Okay. All right. That's probably the weirdest one we got. And let's see. Got an indefinite finally, so they're shorter. Yeah. All we got to do is get the antiderivative part. So I'm going to rewrite this so we can use our reverse power rule. So what's that going to be? X to what power? 9/8. That's right. The index on the radical goes in the denominator. Then we just use our rule. We do have fractions involved, so it's a little bit messy, but if we add 1 to the exponent, that's adding 8 over 8. So we get x to the 17 over 8 power. And then we're going to multiply by 17, divide by 17 over 8, so that means we flip and multiply. Yeah, 8 over 17. And we're almost finished. What's left? Plus c. And our constant of integration there. Questions on that one? Yep. Yeah. So yeah, I'll put a little note in. Yeah. So we had 9 over 8 plus 8 over 8. That's right, because that's 1. I don't know why I wrote it 2 different ways. But Anything else on that one? Okay. Hey, we got another indefinite. It's kind of long, but don't panic on these because they're not as long as it would be if it's definite. Okay. So we're just going to get a function. So, and it doesn't look like we even really have anything too tricky on here. It doesn't look like we have to rewrite or anything. So. Just using the reverse power rule a lot. Okay, so add 1, we get u to the 8th. Divide our coefficient was 1, divide that by 8. Next term, we add 1 to the exponent, we get 7. We had a negative 6 out there, so we got to divide that by 7, so negative 6 over 7. Next one, if we add 1 to the exponent, we get 5. We had a negative 1 out there, so we got a negative 1/5. And then we got a constant at 6 over 5. So if we have a constant, then what do we have to do to get an antiderivative? Yeah, just add a u to it. Add a variable. Whoa. That part of my screen, let's see. Computer's kind of hot, so maybe acting up a little bit here. And then we got one more thing. Plus c. Plus c. Yep. Okay. And thank goodness we don't have numbers we have to plug in there, right? We could do it, it's just annoying. All right. Number, what are we at, 9? Okay. Nothing fancy on this one. Don't panic because we got an e and a sign in there. We can just go straight to getting an antiderivative. So the antiderivative of 8e to the x, 8e to the x, yeah. Okay. And then the 9's a constant, so we can just, we're never going to have a 9 something. Okay. Then we need the antiderivative of sine. Is it? I don't know. We got, I'm having to stop. Yeah, so the derivative of sine is cosine. So if we wanted to end up with sine, we would have to take the derivative of negative cosine. Okay. That'd be, yeah, that'd be sine. Yeah, so we get negative cosine, so negative cosine. Now I got numbers to plug in. Don't panic about the e part. If it doesn't simplify, it doesn't simplify. Okay. It's okay if we have an e in our answer. So here we got 8e to the pi. Okay. Minus 9 cosine of pi. Minus 8e to the 0th. Minus 9 cosine of 0. So let's see. E to the pi, that does not simplify. Minus 9 cosine of pi. Make sure you're in radians. Okay. I'm in degrees. Let me switch over. Okay. So cosine of pi, if you're better at trig, you might remember. Yeah, cosine of pi is -1. Okay. And then minus 8e to the 0th. What does that give us? It's just 8, yeah, 8 times 1, right? E 0 is 1, so that's just 8. And then cosine of 0 is 1. That's just minus 9. Okay. So let's see, that's 8 e to the pi plus 9. And then we got minus 1, or minus and minus 1, so plus 1. So that's 8 e to the pi plus 10. That's fine. That's a number. So okay. Questions on that one? Need to back up. We're going to see it better. Any part of that one? I'll post this after we get done with it. Okay, if you want to add it there. Okay. 10 says use substitution. Or use the given substitution. Okay. So it says use 7x for u. So if 7x is u, what will du be? 7 dx. Yeah, 7 dx. Okay. All we need left over is we just need a dx. So we can divide both sides by 7 or multiply both sides by 1/7. Okay. Well, when we rewrite this thing in terms of u, we'll have a constant factor of 1/7 out front. Cosine of u du. Okay. The antiderivative, so antiderivative of cosine, sine, plus c. And then what's next? Yeah, undo our substitution, So we'll have 1/7 sine of 7x plus c. Okay. Question on that one? Yep. No, probably what I'll do is I will probably put this in the instructions at the beginning of the section. Okay. And then you just got to know if you're doing indefinite, you need the plus c. Because sometimes you don't see it as much nowadays, but sometimes in some textbooks you'll see plus k or some other constant that they're using for the constant of integration. So it's only telling you that so that we're on the same page of what we're using to represent our constant of integration. You can call a constant anything. Other questions on that one? We could even make it like real confusing and say use sigma for the constant of integration. Okay. Or use a squiggle that looks like an integral symbol for the constant integration. Well, we got substitution again. Tells us what to use for u. So if u is x to the 5th minus 6, what will that give us for du? If we take the derivative. 5x to the 4th, and then have our dx. So if u is the x to the 5th minus 6 part, the part we need left over in du is x to the 4th dx. So our adjustment, you can either think about multiplying both sides by 1/5 or dividing both sides by 5. That'll make it match up. So that constant factor of 1/5 we can put out front. Either you can write it either 1 over u du, or you can write it du over u, whichever way you prefer. And we just need to remember how to get the antiderivative of 1 over something. 1 over a variable to the first power. Remember what that one is? Natural log of absolute value of u. And then we can undo our substitution. So we'll have 1/5 natural log absolute value of x to the 5th minus 6 plus c. That's the one power of a variable where the reverse power rule does not work. Because if we tried to move it up to the top, we'll get u to the -1. So then if we add 1, we'll get u to the 0th, and then we would have to divide by 0. That would be undefined. So if you run into that dividing by 0 situation, try to help that let you remember you got to do something else.
So there can't be an undefined?
Not for antiderivative. We won't have anything where you get undefined. Yeah. That's okay. Okay, so the x to the 4th doesn't go into the 1, it goes into the du. Because the 1/5 du is x to the 4th dx. Yeah. And you can either write it out to the side like I've got it, or you can write the du on the top, either way. Yeah. Questions? Okay. How many more of these we got? One more. Okay. Yep. Okay. Oh, all right. Well, forget 12 then. Yeah. No, yeah. I don't know. Haven't made it yet. Yeah. Somewhere around 11. Yeah, 12. So 12 is one that we just saw today because I thought we didn't have one, and then I didn't talk about it. So don't worry about that one. Okay.
You should make it bonus.
Maybe, yeah, might do. Yeah. Might do something like that. Yeah, it is. That's a lot of. If you can do antiderivative, man, you're in good shape. Sadly, what that goes back to is if you can do derivatives, because then you can do them backward and you're in good shape. Yeah. Yeah, if you got one. Yeah. Okay. All right. Okay. Anybody have any other questions? Number 5's answered. Yeah. It'll take it a second to show up, but it'll come down. Number 5, I got 302. And I'll post this too. I mean, let me stop the recording and then we can look at whatever else we need to.